Okay.
Who's the video camera?
Hi, welcome to another PSDcast from Power Systems Design. I'm your host, Alix Paultre, and today I've got Skip Ashton. He's the Vice President of Engineering and Software at Silicon Labs. And, we're going to talk a little bit about the Internet of Things, and it's really a lot going on. And, you had a presentation earlier today where you were talking about we're in a very complex stage right now, aren't we?
The Internet of Things is in a very funny spot right now. So for years we've been writing about the hype cycle of it, and now in the past year it's more fashionable to write about all the bad things with the Internet of Things. And from our standpoint, we're still seeing tremendous growth. The only big change has been the articles people are writing, of course.
Well, and that's the problem is every disruptive technology goes through phases, and IoT has gone through its initial phase, hype and promise, and now people are looking at the rough details, and that's where the negatives are not coming from.
That's right.
It can't do this, it can't do that. Of course it can't do that yet because it hasn't been designed for that application, and it's going to eventually migrate into it. But what are your views on that?
Well, we've seen every technology grow, right? And the Internet had its fits and stumbles. We can still talk about security on the Internet and things like that. And the IoT is going through many similar things. It's going through them at a more rapid pace because, of course, we're taking advantage and lessons from all the previous things. But people trying to get product out are trying to get product out. They're not sitting and saying, well, let's study all the lessons of the past 10 years. So there's going to be a certain amount of fits and starts. There's going to be a certain amount of problems out there. And it's one of these funny things where, 2 years ago we were writing articles about how updating software is a wonderful thing in the Internet of Things, right? Nest had the issue with the wave to hush on their Protect, and they turned it off in people's systems, said this is a safety issue, we're going to turn it off. We reached into everybody's homes and we turned that off through your software. That was a wonderful success of IoT. And now we write articles, updating software on devices is dangerous, you can break things and stuff like that. Well, which is it, right? Well, it's both.
Well, and that's the key, right? It's like the blind man and the elephant. It all depends on your perspective.
That's right. And so what we see is some of the early products got really great acceptance, right? Consumers like them, people do them, and as we try and expand the use cases, we're still stumbling over things, right? And the biggest things we see people stumbling over are interoperability and ease of use, right? The consumer expectations for simple devices in their home are actually really hard when you get right down to it, right? Your light switch and your light, right, have a connection that you don't think about. They work every single time. And so we've spent billions of dollars on cell phones. Have you ever dropped a cell phone call? How's that possible, right? Yeah. We spend tremendous amounts on Wi-Fi infrastructure. Are there places in your home where you don't get good Wi-Fi? Sure. We don't think that's a big deal. You move. The issue with your device, your thermostat's not going to move to the next room and say, I couldn't get a good connection over there. Your light switch, your light bulbs, they can't move. And so the reliability, the ease of use, the interoperability of these devices is a new level that's actually really hard, and people don't think about. I'm just going to make a connected device. It's going to be really cool.
Right. Well, but that's the key here because Silicon Labs just recently came out with the multi-protocol device, and that directly addresses that issue because half the problem is just the connection. A lot of people don't have the right protocols. They don't have the right connection. Do I use Thread? Do I use Zigbee? Do I use Wi-Fi?
That's right. And so we're seeing a tremendous growth in using a point-to-point connection to set devices up, to set up advanced scenes and controls and things like that, using Bluetooth to your phone. It's a natural fit. I've got a great graphical interface on my phone. I can do wonderful things with it. My normal operation still happens with the switch. So multi-protocol really solves some of these basic use cases around ease of use and around interoperability and the reliability for the consumer. And so we see tremendous growth there.
Can you tell us a little bit more about, I just mentioned it, but can you tell us a little more detail about the part itself?
Sure. So the which part, of course?
The Gecko.
Yeah. So the wireless Gecko, we have a family of parts here. So there's Bluetooth-specific parts, there's proprietary-specific, but the Mighty Gecko itself can move between protocols. So it's got a flexible radio. I can configure it to run Bluetooth. I can configure it to run 15.4 like Zigbee or Thread. I can configure it to run proprietary. And so we literally have people that want to do Bluetooth configuration of devices to run on Zigbee or Thread. They want to do Bluetooth and then run a proprietary network, or they want to be running on a Zigbee or Thread network and do Bluetooth beacons for location and things like that. And so this part is capable of doing all those things really through the magic of software, of course, is switching back and forth on the fly in the operation of the radio and the software stacks.
Excellent. Now, granted there is going to be an element of drop-in, but any engineering device is going to require some dial-in to be optimal performance. What kind of support do you offer the clients that want to throw that in?
Yeah, so we actually have, we spend a lot of time on this, right? So these protocols can be complicated, and many of the people we're talking about, as we've gone into a much broader market here, they're not used to dealing with these protocols, with these application layers. We offer a full tool suite that provides an application layer and really an application builder. So through a GUI interface, they can decide what they want their device to be, what software stack they're going to use. Does it need a bootloader or not? What kind of security is it going to use? And those are all configurable in a GUI, and then we generate the customer's project file. Mm-hmm. So they have the source for this application and things like that, and they can go in and change it, but they can configure through a GUI, and they don't have to cut and paste between all these various files and things like that. And then, of course, we offer full support and things like that, and we spend a tremendous amount of time with our customers. And we spend a tremendous amount of time ourselves on interoperability testing. You know, we're on the board of Zigbee, we're on the board of Thread, Connected Lighting Alliance, and things like that, because this is so important to us that these devices be interoperable, because that's the only way the market really grows.
Well, and something my audience has heard me say many times is you could have pixie dust and magic on the inside of your box, but the outside of that box has to talk to the rest of the industry in a recognizable fashion.
That's right. And that's you know, I started with a proprietary wireless mesh way back when. We don't want to talk about how long ago that was, right? And so from our standpoint, we made a very fundamental decision. This is back in 2003, right? A proprietary mesh is a wonderful thing. It worked great. You can't grow an industry that way. You can't grow a real business that way. You need to be standards-based if you're going to connect between things. If you look at the home, if you look at a business and the types of devices we're going to connect together, there is not one manufacturer that's going to make all these devices. So the only way you can really see them work together is to use an interoperable standard.
A lingua franca for all devices.
That's right. And that's been very painful. We've been working on it 10 years. But we're actually getting to that point with IP connectivity down even to these small devices that just wasn't possible 5-10 years ago to shrink it down. And so Thread's the latest of that to really allow IP connectivity down to these small battery-operated devices. So now I have a connectivity between all my devices using IP, which is what we're used to across the internet. So my Thread-connected light bulb looks like an internet-connected device to the rest of the world. It's using IPv6, and we're compressing, we're doing all sorts of things to make it more efficient for these small devices, but it looks like an internet-connected device. So once we agree on the application layers across those connections and that convergence, then we really do have a lingua franca for the devices.
Excellent. Well, hey, Skip, I really appreciate you taking the time to talk with us, especially at a busy event like this. So, and I'm going to drag you back on the show, so you're warned.
Absolutely. Great to talk to you.
The pleasure is mine. And I'd like to thank everybody out there in the audience for taking the time to be with us. We wouldn't be here without you. Tell your friends. This is Alix Paultre for Power Systems Design. Have a great day.